I think it's important to start, as we think about generative AI, it's important to get the context of artificial intelligence in general, and really understanding where generative AI fits in the world of artificial intelligence. And the reality is artificial intelligence is not a new phenomenon. It was really a phrase that was coined in about the 1950s by Alan Turing or John McCarthy, I think, are the two kind of godfathers of artificial intelligence. Artificial intelligence, I think, is a little bit of a misnomer as far as what it actually represents. I think the word intelligence is a bit misleading. Because as humans, we know intelligence really, it can be generally defined as our ability to laterally think across different tasks. It's our ability to do different things gracefully and completely. And artificial intelligence is really about computers being able to behave like humans, but for the most part, it's really narrowly focused. So artificial intelligence, the idea came in the 50s. In the 60s, 70s, the idea of machine learning, being able to teach a computer to think like a human, was a concept. Really didn't really take off as far as becoming something that was practical until the 80s. And then as machine learning became possible through the power of technology and the data that was available, the idea of being able to do deep learning, these are all phrases you've probably heard. They are related to each other, but they are relatively new in the timeline of artificial intelligence. So deep learning was something that became possible really in the 90s, early 2000s as the computing power and data was available. So, I think that breaking down the concept of artificial intelligence into three categories is necessary so that we really understand what kind of artificial intelligence we're working with. The first category of artificial intelligence is called narrow intelligence. It refers to artificial intelligence systems that are designed and trained to do specific tasks. They do them really well, and a lot of those tasks maybe were tasks that humans did before, but really it's focused on doing the individual task. The email spam filter that you use on a day-to-day basis, you don't often think of that as artificial intelligence because we've just become accustomed to expecting that will work, and it does, and it works great. But it is in fact, an AI that does one specific thing really well. Maybe not impressive, maybe not as impressive as Tesla. Tesla, who's out there trying to teach a car how to drive itself. It obviously is learning a task that's different than an email spam filter, but it is in fact an artificial intelligence that is purposely built and is narrow in its applicability. So, your Tesla is not going to be able to manage your spam, and your spam is not going to be able to drive your car. But as humans, we are able to work across those two things and many more on a given day without any problem. So, that's the first category of artificial intelligence, and we'll talk a little bit about more about that in a second. But the second category is the concept of general intelligence. And I say it's a concept because it's not something that we have achieved as a society yet, but it is something that I think gets invoked a lot in the headlines and is talked about. But the idea is that the computer basically can put together many narrow intelligence to function more like a single human being. Has human-like cognitive abilities and enabling it to understand, learn, and adapt to a wide range of tasks. The interesting thing about general intelligence is it's something that academics and futurists who think and debate this topic it's not something that is debated on if it will happen. It is debated on when it will happen. When will we reach a point where we have achieved general intelligence? And the crazy thing is while that debate has carried on for decades, largely the time frame in which it's believed that we will achieve general intelligence really is probably in the ranges of late 2020s to late 2030s. So it's on the horizon as far as the computational power and data that's required to be able to achieve that is becoming more and more available to us. Now, the third category of artificial intelligence, if general intelligence is considered the idea that a computer could behave like a human. Super intelligence is, I guess, the easiest way conceptually to think of that is that a computer could function like all humans combined and have the knowledge and decision making of many, if not all humans combined. And again, it's a concept. It's not something that we have achieved, despite all the headlines about the robots taking over. It's a concept that describes that phenomenon. It is also something that those who study this do not debate whether it will happen. It's just when it will happen. And that's something that if we look at how long it took for us to get from narrow intelligence to general intelligence, how long will it take for us to get from general intelligence to super intelligence? There's a wide range of opinions on that. And it goes anywhere from a couple decades to a couple of days. So it's an interesting concept that it may be not so far off as you think. But that's not what we're here to talk about today, because what we're here to talk about is generative AI and how it fits into our lives and how it fits into our businesses and how it matters to the people that we engage with through marketing and advertising. And to really dig in on narrow intelligence, we live in a world of narrow intelligence. I gave the example of the email spam filter. The email spam filter has this relationship to machine learning. It uses a thing called the Bayesian classifier, which uses an algorithm or a theorem called Bayes' theorem. Again, this is just demonstrating that the idea of AI is grandiose, but when you think of it on a narrow intelligence level, this is how these things work. Similarly, in our business, we rely on platforms and programmatic buying tools that help us optimize our buys on a daily basis, minute by minute, second by second. And that display optimization engine is a narrow intelligence that uses a machine learning thing called lookalike modeling. We've all heard that term. Lookalike modeling uses an algorithm called the k-means clustering algorithm. I'm generalizing a little bit on how some of these things work, but at its core, this is the relationship between AI, narrow AI, and some of the things we see every day. Now, generative AI, which is a new phenomenon that has come to be popularized in 2023, really with the advent of ChatGPT, is also a generative AI, or it's also a narrow AI. So generative AI uses what's called a large language model. You've probably heard that term, which uses a neural network to be able to compute data at scale. And so, generative AI, there's a little bit of trickery in why we maybe are reacting to generative AI different than how we've reacted to the email spam filter or the Tesla driving itself. It's because for the first time, it's a computer that's generating new and novel content that feels very human-like. And so it's easy to kind of transition into that thought of general intelligence or super intelligence, but in fact, it is just a computer doing one thing really, really well. So I want to unpack what it's doing a little bit, because I think it will set up some of the other sections and other content that we're talking about today. So I want to unpack what a large language model is and how it works. So how a large language model works. I do want to give credit to Steve Seitz, who's a professor at the School of Computer Science at the University of Washington, for giving me this analogy. But we can kind of inspect how a large language model works by looking at something familiar to our day-to-day lives. And it's, everyone uses a smartphone, and we all probably benefit from the predictive typing that happens on our smartphone as we're going. So as we're in this example, if you were to type the letters TY, and you were to look at in the English dictionary what words start with TY, and we were to order them in length, you would get these options of this. This might be what you're typing. But behind the scenes, your phone knows how often each word is used. If you actually, the source of this graph is Google Books, and you can go and look how often a word is used in written written language all the way back to the 1800s. And in the 1800s, TYE was used a lot, and now in the 2000s, it's used very little. In fact, it's used so infrequently, I think the math works out to you'd have to read something like 20 million words before you'd come across the word TYE. So if we take those probabilities, and this is what's happening on your phone in real time, is looking at the probabilities of the words that may fit the letters that you're typing, and you were to organize those words in order of probability, your phone is going to predict that you're going to type the word type. And so really, at its core, that idea of probability is how a large language model works. In this case, it's taking, what word are you typing given the letters that that you've already typed, and it can predict with what feels like a pretty good accuracy the word that you're trying to get to. Now, we can apply that same concept to more words to create a language model. And in this case, we'll use a verse from a Bob Dylan song, Tangled Up in Blue. So in this, taking the same principle of trying to predict, in this case, what's the next word given the previous word, we can take this verse of Bob Dylan's song and we can look at it as a time series, meaning, one word's following the other. And if we can look and find in this verse reoccurring words and reorganize the verse into what is called a graph. This graph shows that this sequence of wording happens still linearly, but it removes the redundancy. And if we add probabilities of one word coming after the previous to this graph, we can recreate that verse from Bob Dylan using these probabilities and being able to recreate that whole section. This is a language model. This is taking one verse, looking at the relationship of the words, applying probabilities to one word coming after a previous, and that creates a language model. And in this simple language model example, we can use that language model to create new, novel, unique Bob Dylan sounding lines like her hair was shining, sounds like something Bob Dylan would write, or the sun was still red. So using that language model, we can create new language, in this case, lyrics for a Bob Dylan song. But it's a simple language model and would quickly fall off the rails. If you kept playing with the relationships here, we'd get things like the sun was laying in bed, which doesn't make a lot of sense. And so this example demonstrates that if we take the core concept of probability and apply it to written language, we can use that to be able to scale prediction on one word following the previous. This example, being overly simplified, means that the idea of being able to take that principle and apply it to not just Bob Dylan's verse or Bob Dylan's song or Bob Dylan's catalog, but what if you were able to take that concept and apply it to a lot of data, and that's kind of the ambition that the people over at the computer scientists over at OpenAI had when they started to create ChatGPT. They started this endeavor in 2017, 2018, and their ambition was, rather than looking at some written language, what if we analyzed all written language, all the written language that's been published on the internet from the beginning of time? That's hundreds of billions of web pages of written word that only recently would be able to be processed because that's the computing power was available. So being able to build large language models is something that really only became possible starting in 2017, 2018. But it's with this exact principle, this very simple idea of, can we predict one word coming after the previous word, or one word coming after the previous three words, or the last sentence, or the last paragraph? So building a large language model is really teaching a computer to process all of that language and find the patterns, and then being able to use those patterns to create new language based on interaction. We could use it to write a Bob Dylan song pretty accurately. So, hopefully that helps bring some context and clarity to what generative AI is. In this case, we're really talking about generative AI as it relates to text. There are other generative AIs that create music or create imagery or pictures, but they all work with the same principle. Rather than predicting what's the next word given the previous X number of words, it's, in the case of images, it's what's the next pixel given the last X number of pixels. So the large language model, I think, serves that purpose of understanding how those things work. And those are experiences that we're having every single day. But, I think that because this has happened relatively overnight, the generative AI phenomenon really became popularized in late 2022, early 2023. And what's interesting is I subscribe to this kind of chart of technology advancement. It's the idea that technology advances at an S curve, where there's a plateau and then a rapid point of growth that exponentially happens, and then it plateaus. And while that's plateauing, there's new technology that's coming along. It's going to be that step change that we see in our world. I believe, and what we're experiencing right now, is that generative AI can be that vehicle to drive us forward as a society and bring some new technology experiences to life. But we're very much at the beginning of that. We're very much within 18 months of that actually becoming true. And so, something that we have been taking on within our organization, we're trying to understand how generative AI impacts the work that we do, how it impacts our processes, how it impacts our tools, how it impacts the product and services that we bring to our clients.